we will learn how to solve absolute value equations. The most important thing that we will need to remember to be able to solve these absolute value equations successfully is that there are going to be two solutions to satisfy all absolute value equations. Because if we recall, the definition of absolute value is how far a number is from zero on the number line. So there are always two numbers that are the same distance from zero on either side of zero on the number line. So throughout this whole video, try to keep that in mind. Okay, so for our first example, we have here that the absolute value of p plus 5 equals 11. So what number plus 5 is 11 spaces from 0? The first thing we want to do here is just get rid of anything extra on the side of the absolute value so that we are only looking at the specific value, how far it is from 0. So that's step one. Always isolate everything except the absolute value expression, which in here is the absolute value of p. So now that I have just the absolute value of 6, if we consider our number line, here's 0, what values are 6 spaces from 0? Well, we know that to be positive 6 and also negative 6, so we will write both of those as our answers. Seems fairly simple. Let's take a look at another one similar to example 1. Again, the very first thing we want to do is isolate just that absolute value because that's the one I'm trying to find how many spaces from 0 it is. So we do that by adding 2 to both sides first to get rid of the minus 2 since it's not inside the absolute value, and then dividing both sides by 3 to isolate the absolute value. Now we want to think about which numbers on the number line are 2 spaces from 0, and we know that to be positive 2 and negative 2. Let's kind of generalize this when just the only thing inside the absolute value is a variable and the absolute value is something bigger than 0. We're going to solve for a and then identify the two possible solutions as b and negative b. Those are the examples that we just did a moment ago. Now let's take a look at something a bit different. The absolute value of the quantity of p plus 5 is 11. So what I want to know is, what would p have to be to make this quantity 11 spaces from 0, because it's a whole quantity inside the absolute value. So we know that 11 spaces from 0 are 11 and negative 11. But I want to know, what does p plus 5, that whole quantity is negative 11, and that whole quantity could be positive 11. So we need to figure out what would p have to be to make this quantity equal to positive 11 and negative 11. You can do this in your head if you'd like, or you can write it out. We need to know what is p so that p plus 5 is 11, and what is p so that p plus 5 could also be negative 11. In this example, since we have a whole quantity inside of our absolute value, we are not going to get the same thing but opposites. In all of our previous examples, our answers were like 2 and negative 2, 6 and negative 6. This is different because we have an entire quantity that needs to be 11 spaces from 0, not just p. So we need to take into account if this is something plus 5 is 11 spaces from 0, what would I add to 5 to get to 11? And that would be 6. On the other side, I have something plus 5 has to equal negative 11. So if I'm here and then I would add 5 to get to negative 11, I would have had to have been at negative 16. So a little bit different than our last examples. Let's try another one. Okay, this one has more than just the absolute value. So again, our first step is always to isolate that quantity, whatever is inside the absolute value. So we're going to do that first by adding 4 on both sides, which gives us 15 equals 3 times the absolute value of 2x plus 1. And now we're going to divide both sides by 3 to get 5 equals 2, the absolute value of 2x plus 1. If we think about that number line again, we want the quantity of 2x plus 1 to be 5 spaces from 0. So this whole quantity has to equal either 5 or negative 5. So we need to now, our goal is to figure out what value of x will make that entire quantity equal to 5, and what value of x would make that quantity equal to negative 5. We can set those up as I did below and solve them for x. Oops. To get x equals, x would have to be 2 in order to make this quantity equal to positive 5 spaces from 0. And we have over here x would have to be negative 3 so that this whole quantity would be negative on the 5 spaces from 0. Now let's take a look at what happens if I have 2 absolute value quantities on either side. We know that the absolute value is always positive. Okay, so we can think of that the value of n here could be positive n spaces from 0 or negative n spaces from 0. So what we need to do is show that by setting up this side of the equation to equal both of those things. We can then solve it both ways by canceling out that 4n and solving for n. That's supposed to say 5 equals n. My pen is going a little bit crazy. And over here we have 3 equals n. Here's a challenge one for you to try if you would like. So when you're solving, this is the second type, when the inside of the absolute value is an expression and not just a variable, you need to solve that expression for positive b and for negative b. What do we know can never be true for absolute value? Absolute value can never be negative. So one thing to look out for is if you see the absolute value set to equal a negative number, we know that that's not possible. Sometimes we still might want to isolate the absolute value just in case, but it's not possible for the distance from 0 to be considered a negative because we don't measure distances in the negative. So for problems like this, we say that it has no solution. Taking a look at these problems, which ones of these would you say have no solution? I'm not sure what happened to the formatting of this one, so we can just ignore that for the time being. But which ones would you say have no solution? Oh, I see. This is supposed to be negative 14 over here. Somehow it got pushed to the other row. And this one here is, I think, supposed to be this. There we go. Now you want to be careful. Just because it looks like it equals a negative might not actually be the case. This one looks like it's equaling a negative, has absolute value equaling a negative. But remember, we have to isolate that absolute value first. And if I do that, then I actually get a positive. So this one does have a solution. This one looks like it has a solution, but if I isolate that absolute value by subtracting the 3 first, I'll notice that this one actually does not have a solution. This one would have a solution because if I add 2/3 to 5/6, that's going to be a positive. So this one has a solution. This one has a solution. This one looks like it has a solution until you realize you have to isolate the absolute value first. And once I do that, now we can see that this one does not have a solution because it cannot be negative. This one appears that it does not have a solution, but we have to first isolate the absolute value and see if that's still true. When I have this quantity and divide it by -3, 2 negatives will cancel out, so we actually would find out that this one could have a solution. And then lastly, this one would not have a solution because there's nothing else to do over here. We just have an absolute value expression, nothing outside of it, so this one has no solution. One thing that you don't want to do is you never want to distribute into an absolute value. It will work for a positive number and it will still give you the same value. It will not, however, work with a negative number.